Hello and welcome. Reactance is the opposition to the flow of AC current offered by an inductor or a capacitor. So whenever there is this opposition to the flow of alternating current, when there is an opposition to the flow of alternating current, we have what we call reactance. If it is caused by an inductor, it is known as inductive reactance. If it is caused by a capacitor, it is known as capacitive reactance. I've looked at capacitive reactance in the previous class. Today we're going to be looking at the inductive reactance, that very opposition caused by an inductor. And in such a circuit, we have the current lagging by 90 degrees, unlike that of a capacitive reactance where we have the current leading the voltage by 90 degrees. In this case, the current is lagging behind by 90 degrees, or by pi over 2 radians, or by 1/4 cycle. So let's look at it critically. Inductance in an AC circuit. Reactance is the opposition to flow of alternating current, AC, offered by a capacitor or an inductor or both. So in this case, it is offered by an inductor, so that it is known as inductive reactance. In an inductor circuit, the current lags behind the voltage by pi over 2 radians, or by 90 degrees, or by 1/4 cycle. This is opposite to what happens in a circuit that has a capacitor instead of an inductor. So this inductive reactance is equal to 2 pi FL, where L is measured in Henry. So let's look at this example. Find the impedance or inductive reactance across an inductor of 0.2 Henry inductance when an AC voltage of 60 Hz is applied across it. If the voltage is given by V equal to 150 sine 120 pi t, remember this expression, that the peak voltage at any point Vt is equal to the peak voltage, that's VO. This is VO sine W pi t. Now calculate the root mean square or peak values of the current. To do that, first of all, you calculate the resistance, which is the inductive impedance or the inductive reactance, just the way we did in the other one, XL. That's what you must calculate. If it's for capacitive reactance, you have to calculate XC, but here we are calculating X subscript L, which is equal to 2 pi FL, which is equal to 2 pi, F is 60, L is 0.2, to give us 75.40 ohms. So that is the inductance or the inductive reactance. Now, since V is equal to 150 sine 120 pi t, we can easily deduce here that VO is the 150. And we know that the V root mean square is simply 0.7 times VO. That is 0.7 times 150 to give us 105 as the peak VO. So now, to calculate the root mean square value now of the current, is going to be V arrow root mean square over XL, and V arrow root mean square is this, which is 105 all over 75.4 to give us 1.38. So this is the root mean square current, and the peak current is going to be the peak VO all over the XL, and the peak VO or the peak voltage is 150, and XL is 75.4, which we area calculated. So if you divide 150 by 75.4, you get 1.99 amperes, and that is the peak value of the current. You can see that it is higher than the root mean square. So that is how you do the calculation. Any calculation involving inductance or impedance or capacitance, you have to first of all calculate the XL. And important things to note here is that the formula is XL equals to 2 pi FL. If it is SC, which is capacitive reactance, it's going to be 1/2 pi FC. So in the subsequent class, we're going to be learning about impedance. So also note that in an inductor circuit, the current lags behind by 90 degrees, or pi over 2 radians. So that's where we're going to be stopping. If you have any questions and concerns, please drop them in the comment section. Like and always share our videos. Thank you and God bless you.